Okay, good morning. We will start with exercise 11.3 where we are going to deal with all the three solids simultaneously. That is the cube, the cuboid and the cylinder. I forgot to tell you yesterday the formula for the CSA and the TSA of the cylinder that we derived in the practicals should be transferred to the formula page in your classwork. If you have done it, it is very good. Otherwise, you can do it now. It will take 2-3 minutes. Even if you are not able to draw the cylinder there because of shortage of space, at least the CSA, TSA and the volume. The volume also I'll tell you now. Please write it down in the formula page. The CSA, the TSA and the volume. Get back to the formula page because now we will be using it frequently for the cylinder. If you are able to draw the figure, fine. Otherwise, never mind if it is not possible. The height, the radius. So CSA is 2 pi r times h. TSA is 2 pi r times h plus r. And the volume is pi r square h. So these are the three formulae that you have to write in your formulae page. I wrote it in a inclined manner because there was no space, that's all. Don't think why I am writing it like that. The cylinder with the diagram, maybe the diagram you can draw later leisurely after the class. The CSA, that is the curved surface area for the cylinder is 2 pi r h. The TSA of the cylinder is 2 pi r times h plus r and the volume is pi r square h. So this should be quoted in your formula page because we will be using it time and again in this exercise. Alright. So we will move on to the exercise 11.3 where we will take up the second problem. Can I clear the board?
Can you say what is the pi r square multiplied by h from the volume formula?
Volume formula. Pi r square times h. That is pi into r into h. In all the three cases, your pi value will be taken as 22 by 7 or 3.14. Any one of these values you can use. It may be specified in the problem sometimes. If it is not specified, either one of them you can use. Any of them is okay. Now we'll move on to the second problem. Can I clear the board? The second problem in exercise 11.3. Let me read the problem first, try to understand the problem, then we will move on. Am I within the... Okay. Okay, I covered till here, is it? Then I think I can use a little more to the side. Am I visible till here?
Yes, ma'am.
Okay, good. Let me read the second problem. A suitcase which measures 80 centimeters by 48 centimeters by 24 centimeters is to be covered with a tarpaulin cloth. Now this the suitcase has got three dimensions, that is 80, 48 and 24. Because there are three dimensions given, can you guess what is the shape of the suitcase?
Cuboid.
Yeah, it is a cuboid because all the three dimensions are different. One is 48, one is 80, another one is 24. If it were a cube, all the edges would have been equal. Now, because the edges are of three different sizes, the shape that we should imagine definitely is going to be a cuboid. Now, this cuboid is going to be, or the suitcase is going to be covered with tarpaulin cloth. So, where will the tarpaulin come? Have you seen suitcases covered with tarpaulin cloth? It is a cover which is avoiding scratches on the suitcase. We usually wrap it in a cover and then there will be zips on all the four sides. Have you seen this?
Yes, ma'am. In American Tourister suitcases, they used to do.
So where will this tarpaulin cloth come? Will it come on the top or will it come at the bottom or will it come on all the sides?
Ma'am, all the sides. If it is covering means all the sides.
Ma'am, all the side.
It has to be covered. It has to be coming on all the 6 faces of the cuboid. So the question is, how many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases? So there is a company which is going to manufacture the covers for suitcases. So they need to manufacture 100 covers, and they have cloth or the tarpaulin whose width is known to them. They have to find out how many meters of tarpaulin they have to buy so that they can stitch covers for 100 such suitcases. So first thing I have to imagine is the suitcase is in the shape of a cuboid. So you will draw a cuboid neatly in the center of the page. I told you mensuration always the figure should come in the center of the page, and below that only you will start working. Alright? Okay. So the length is given as 80. The breadth is given as 48. So the breadth, and the height is given as
24.
24 centimeters. So these are the three dimensions here. And I need to calculate the TSA or the CSA. Because the cover is coming on all the 6 faces, I need to calculate the TSA of the cuboid or the CSA of the cuboid.
Ma'am, TSA, total surface
Yes,
area.
the total surface area, because the top, the bottom, and all the 4 sides are to be covered with the cloth. So what I need to calculate is the total surface area of the cuboid. So let us write first the formula for the TSA of suitcase. Within bracket you can write it is a cuboid. Only then you will be able to substitute the formula. Now go back to the formula page and find out what is the total surface area of a cuboid.
Ma'am,
We
2
have written it down in the
into
formula.
LB plus BH plus
2
HL.
times LB plus BH plus HL. Correct? Yes or no?
Yes, ma'am.
2 times LB plus BH plus HL. So substitute LB and H in this formula. 2 times L is 80. So LB means 80 into 48 plus B is again
48,
48 into
48 into 24.
plus
24 plus 24 into 80.
plus HL 24 into 48. Sorry, 24 into 80. Sorry. So come on, start multiplying all the 3. You should get 3 products there. Do it. 80 into 48. All the working space you can use there.
Ma'am, 3,840. First one, ma'am.
80 into 48. Yes, loudly.
Ma'am, 3,840.
3,840.
Yes, ma'am.
Next, 48 into 24.
Ma'am, 1152.
1,152 plus 24 into 80.
Ma'am, 9,000.
Right,
Ma'am,
9,000.
1920.
1,920.
Yes, 1,920. Now add all the 3 of them and tell me how much it is. 3,840, 1,152 and 1,920. Add it properly.
Ma'am,
16,912.
16,912.
Clearly one of you me.
6,912.
6,912 is the answer I'm getting. Are all of you getting the same?
Yes, ma'am.
Okay, multiply that with 2 now.
Ma'am, 1,300
When you multiply 6,000 with 2, you will get 1,000.
Ma'am, 13,824.
13,000.
824.
So many centimeters square. So this is the area of one suitcase. That is the total surface area of one suitcase. Now, how many suitcases do you require to cover?
100.
So, area of 100 suitcases. Please continue writing below. I don't have place, so I am writing it here. So that will be 100 multiplied with 13,824. So that will become 13824 followed by 2 zeros. So many centimeter square. Correct? Now,
Ma'am, how
the
many zeros are there
cloth
actually?
is having a specific width. The width of the cloth is fixed. Only thing that you have to find out is, yes, Arun?
Ma'am, how many zeros are there? Is it 2 zeros, ma'am?
No,
It's
I
green.
have 2 zeros. Can't see the 2 zeros?
Now it is visible.
So it is, so much is the area of 100 suitcases. Now these 100 suitcases are going to be covered with a tarpaulin. The width of the tarpaulin cloth is fixed. It is told it is equal to 96 centimeters. Now how many meters of the tarpaulin cloth should you buy so that so much area can be covered? So you will write width of the cloth is already given as 96 centimeters. Correct? It is given as 96 centimeters. Therefore, length of cloth will be area divided by width. So, area is 1382400 divided by 96. Now, you have to do that division and tell me how much are you getting. You can first cancel with some common factor because both are even numbers, or you can directly divide with 96. Whichever is feasible to you. Please do it fast. Hurry up. We have to do it a little faster because we are writing it very, very slow.
Ma'am, 144.
Yes, somebody has already arrived at the answer.
Yes, ma'am, 144.
The cost is also asked, no? No, only the meter. Okay. 144 is 96, 144 times is 13,824. There are two more zeros now. That also you have to add. So much is the length of the cloth which will be required. It will be 14,400. Don't leave the zeros while you are dividing. It is 144, this part will be division will be over. Then you have 2 zeros, so that has to be added. So this is the length of the cloth which will be required.
Ma'am, can you move your screen a little to the right side so that it is entirely visible?
Is it visible? I think I will write more on this side because I've not used this
This
side.
one.
No, I'll move this side next problem.
Ma'am, then you will have to turn the laptop also towards that side, ma'am.
That I will do. That I will do as it is required. Okay, can we move on? Next, we will do the third one. Find the side of a cube whose surface area is 600 centimeters square. So there is a cube whose area is given. From the area, you have to find the side of the cube. So let us draw the cube first so that we understand what are the faces that we are having. The third problem, let me see where all I can change. Yeah, I'm visible, no? I'm visible, am I in the frame? Nobody is answering.
Yes, ma'am, yeah, ma'am, you are coming in the frame.
I don't have to be visible, the board has to be visible. I will come in when I require. So that is the cube. So the area is given, I am asked what is the side of the cube. So I will call it some A, which is not known to me. All the edges will be A. Why? All the edges will be A only. Why did I write it as A only? It can be different. No.
Ma'am,
Because
because all are same, we have to use the
all
same.
the faces will be squares. That means all the edges will be of the same length. So the problem it is said the side of the cube is what you have to find, whose surface area is given as 600 centimeter square. So whenever they are simply talking about surface area, you must understand we are talking about the total surface area. If it is curved or lateral surface, it will be mentioned. Simply, if it is said surface area, you must understand that it is about the TSA that they are talking. Okay. So the TSA of the cube, if I am going out of the frame, please tell me. I am also checking, but still, if I miss something. So TSA of the cube is 6A square. That is the formula given to me. I know the TSA of the cube is the sum of all the 6 faces. The front, the back, the top, bottom and the sides. All the 6 faces together will become the total surface area, which is 6A square. Now it is given that this 6A square is equal to 600 centimeters square. Alright, the 6A square is already given to be 600 centimeters square. So from this simple equation that you have, do you think you can find out the value of the variable which is A? Can you solve that to
Ma'am,
get
it
the
can
value A?
divided by 6, ma'am.
6A
Can
square
you
is 600. First transpose the 6 here, that means the A square will become 600 divided by 6. So that means your A square will become equal to 100. 600 divided by 6 will be 100. A square means what? A into A is equal to 100. So that means to find out A, you must find the square root of 100. What is the square root of 100? Which number when you multiply it with itself, you are going to get 100.
Ma'am, 10.
10.
10,
So
ma'am?
your
Ma'am,
A,
10.
you can write A into A as 10 into 10, or in other words, A is equal to 10 centimeters. Therefore, edge of the cube or the side of the cube is 10 centimeters. Completed? We will take up the 5th one next. The 5th problem. Okay, let me read the 5th problem. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height of 15 meters, 10 meters and 7 meters respectively. So it is a cuboidal hall which has got a length, breadth and a height. Now the entire hall is to be painted. Alright. So painting has to be done to cover the entire hall. Now from each can of paint, 100 meter square of area is painted. Alright, 100 meter square paint madbekandre 1 tin of paint is getting used. Now the question is, how many cans of paint will she need to paint the room? So first of all, you have to understand which is the area that you have to find. Daniel is painting the walls and ceiling of a cuboidal hall. So will you take the total surface area of a cuboid or something else is to be avoided?
Ma'am, the top
It
and
is
the bottom surface they will never paint, so that should be avoided, ma'am. Total surface area is not necessary.
then which area is necessary?
Ma'am,
Ma'am,
the sides, the four sides, that is front,
No,
the
let
four
me
sides
read
would
the
be necessary.
problem again. Listen to me carefully. Daniel is painting the walls and the ceiling of a cuboidal hall. It is not only the four walls which is getting painted. The ceiling, that means the top is also getting painted. So can I say if I
but
take the
water
lateral
we
surface
cannot
area, it is
paint
enough?
Ma'am, but we should avoid the ground area, no, ma'am.
Yes,
Ma'am,
correct.
bottom we
Think
cannot
and tell
paint.
me what will you do? Will you take the total surface area or the lateral surface area? Which one should you apply? The TSA or the LSA? Why you are not answering? It is a cuboidal hall. Now I can't tell, I will not paint the floor. Nobody paints the floor. The floor has got tiles to be fixed. So it is only the four walls and the ceiling which is getting painted. So let me first imagine the hall which is in the shape of a cuboid. So which is having a length, width and a height. So let me mark the length is 15, the width is 10, length is 15, the width or the breadth is 10 and the height
7.
is 7. Now the painting is going to happen in the four walls and the ceiling. So ceiling is this. Correct? Apart from the ceiling, I have the four walls which are painted. So which are the ones? The front, the back, the left and the right. So how many faces are you going to paint in the cuboid? Is it 4, 5 or 6?
Ma'am, 4.
Ma'am, 5.
Not 4.
Ma'am, 5, ma'am.
5 faces because the top is 1, correct? Then front is 2, back is 3, 4 sides, left is 4, and the right is 5. So 4 walls and the ceiling. So 5 faces have to be painted. So area to be painted. And take Marita is correct ನೋಡಿ. Area to be painted is equal to LSA, that is the 4 walls. 4 walls only will become the lateral surface area. So LSA plus the top surface or the ceiling. So area to be painted is the LSA plus the top, which is the ceiling. I am writing the bracket as ceiling. So LSA of a cuboid area. Please get back to your formula page and see what is the lateral surface area of a cuboid. Why nobody is answering? Lateral surface area of cuboid 2h into L plus B. Is it there? Correct or not? 2h times L plus B is the lateral surface area of a cuboid.
Ma'am,
Correct or
2h
not?
plus length plus width. Yeah, ma'am.
2h times L plus B. Then top line again. This is the length and this is the breadth. So you will have
LB.
B, which is the area of the top. Correct? Now you substitute the length, breadth and the height. So this will be 2 into h is 7 multiplied by 15 plus 10.
15 plus 10.
And this is 15 into 10. Any doubts so far? 2 into 7 is 14. 14 into 15 plus 10 will be 25. Plus 15 into 10 again is 150. Can you understand what I have done? 2 into 7 is 14. 15 plus 10 is 25. Then I should multiply these two. 2h times L plus B other 2 into h into L plus B. So 2 into h is 14. L plus B is 25. So 25 into 14. Plus the top is L into B, which is 15 into 10, which is 150. Now multiply what is 14 25 times.
Ma'am, 350.
Ma'am, 350.
Yes, 350 plus 150. What is 350 plus 150?
500.
400.
500
500.
500 meter square, sorry, meter square. So this is the area to be painted, alright? The area that you require to paint is 500 meter square. But what is given? The area which can be painted with one tin. Area painted one tin under one tin of paint. Area painted with one tin is 100 meter square. So one tin is 100 meter square paint marble. I have 500 meter square. So how many tins will you require? One tin is 100 meter square paint marble. If I have one tin of paint, I can paint 100 meter square. Now I have to find out the number of tins for painting 500 meter square. How many will you require?
Ma'am, 5 tins,
Ma'am,
ma'am.
5 tins.
Yes, 500 divided by 100, which is 5. Alright? Therefore, number of tins required to paint the hall is 5. You have to write it like that. Clear?
Ma'am, for one tin it is 100. Ma'am, so we should write
So to paint 500 meter square, you require 5 tons. ಒಂದು ಟಿನಲ್ಲಿ 100 meters ಮುಗ್ದೋಗುತ್ತೆ. ನನಗೆ 500 meter square total ಆಗಿ paint ಮಾಡಬೇಕು. So 5 tons ಬೇಕಲ್ವಾ? 100 plus 100 plus 100 plus 100 plus 100. Clear? That's why I have done the division. How many hundreds are there in 500? That is 5. Following? Okay, we will see if we can take one more problem quickly and finish. Yeah, I think we have some 4 minutes. Yeah, we are at the 6th problem, simple one. Describe how the two figures in the right it is shown are alike and how they are different. Which box has larger lateral surface area? So which are the two boxes given? One is a cylindrical box, the other one is a cubical box. Can you see? A cylinder and a cube is drawn there. Now they are asking you to find out how are they alike. Are they alike? It is what it is asked. They are not alike because they are having two different shapes. So you will write they are not alike. The second is, and how are they different? If they are not alike, how are they different? You will write that the shapes are different. Now, which box has got larger lateral surface area? That means you have to compare the lateral surface area of the cylindrical box and the cubical box. So first draw the two figures correctly. You have a cylinder whose base radius is 7 and the height is also 7. Then you have a cubical box. So here the height is given as 7 centimeter, a meter, no centimeter. So this is the height and And the radius is not given, diameter is given. So radius is 7 by 2. Why I have taken 7 divided by 2? What is the diameter? Can you see from one end to another? From this to this, it is given as 7. You can write this 7 if you want. This is totally given as 7 centimeter. This is the diameter. So when I want the radius is 7 divided by 2. Here, all the edges of the cube are given as 7 centimeter itself. So they are looking as though they will have the same lateral surface area. Let us find out if they are going to have a same lateral surface area. So let me start with the LSA of the cylinder first. Both the boxes are not alike. As they have different shapes. Okay? So they have different shapes is what you have to write. Then we will start with the LSA of cylindrical box. What is the LSA of the cylindrical box? What is the LSA or the CSA of the cylinder? Get back to your formula page. That's why I told you formula page. 2 pi r h. So what's your values? 2 into pi, I will take it as 22 by 7. The radius is 7 by 2.
7 by 2
And the
into
height
7.
is also 7. Yeah. Is someone speaking? Yes, tell me. Nothing? Okay. So 7 and 7 will get cancelled. 2 and 2 will get cancelled. In the numerator, you have 22 into 7. That is 154 centimeter square. That is the area of the cylindrical box. Next, moving on to the area of the cubical box. Quickly we'll finish this problem. Area of cubical box. Will be, what is the surface area LSA of the area anta baribedi LSA antane bari, because you have to substitute the formula for LSA. Just now we have seen for a cuboid. Now you want LSA of cube, which is 4a square. That is 4 into 7 into 7. Because the edge of the cube is given as 7. So 4 into 49. How much is that? 4 9 is 36, carry 3, 16, 1 9 is 6. So, are they the same? The lateral surface area of a cube and a cylindrical box? They are not. Which is having the greater surface?
Ma'am, cube. Ma'am, cube.
Right? Therefore, the cubical box has a larger LSA. Okay, so this is the comparison that we have done. The two boxes, their areas, which is the lateral surface, is calculated separately. We are seeing for the cube it is 196, for the cylinder it is 154. So the cubical box has a larger lateral surface area. That is how you have to complete the problem. Clear?
Yes, ma'am.
Yes, ma'am.